Hello dear students, welcome back to EDUHUNT online teaching platform. At the section today we are going to discuss about circle, which is a part of 9th class mathematics. So let's get started. Circles. So firstly, what is the main definition of circle? So what is the definition of circle? A circle is the locus of points equidistant from a single or fixed point lie on the same plane. So a circle is a locus of the points equidistant from the fixed point. So here fixed point is called center. It is called center. So firstly, circle contains circumferences. So what is the definition of circumferences? So the boundary of the circle is known as the circumferences. The boundary means this is a total boundary around the boundary, that is called perimeter. So perimeter also. So here circle, clearly we need to identify that. So circumference means perimeter of the circles. The boundary of the circle is known as circumference. Am I clear? So clearly we need to understand circumference. It can be denoted as C equal to formula 2 pi r. Here pi stands for pi value 22/7. R stands for radius. R stands for what? Radius. So radius. What is the radius? Next definition. What is the radius? Because circumference of circle equal to formula 2 pi r. Here pi value 22/7. 2 is a constant. R stands for radius. R stands for radius. Am I clear? So what is the radius? So the line from the center O of the circle to the circumference of the circle is called the radius, and it is denoted by small r or capital R. So clearly we need to identify that. So what is the radius? So the line from the center O, this is a O. So this is a O, center O of the circle to the circumference of the line. Circumference of the line. So center to circumference of the line. Am I clear? This is a line, so which is connected between center O to circumference of the circle is called radius. It is denoted as R. Capital R, small r. Am I clear? So what is the radius? It is a line which is connected from center to any point on circumference. So that line is the line is said to be radius. So it is denoted by small r or capital R. Am I clear? Next one, diameter. So what is the diameter? The line that passes through the center of the circle and touches the 2 points on the circumference is called diameter, and it is denoted by D, capital D or small d. So diameter, that means it is a circle, it is a center O. So the line that passes through center, the line passes through center, and what I am given touches the 2 points on the circumferences, just like this is 2 points. So radius also, it is a line. So the line passes through center. So here it is a center, nothing but O. Am I clear? So it is a center, passes through center and touches the 2 points on the circumference of the circle. So that is called diameter. It is denoted as small d or capital D. So D. Here D stands for diameter. D stands for what? Diameter. So D can be written 2r also, because half of the diameter is called radius. So what is the radius? Clearly we need to understand that is a line of a circle. It can be taken from the center to any point on the circumference. It is called radius. So diameter, nothing but it is a combination of 2 radius. So 2r. This is also very important point. So it is denoted as small d or capital D. Am I clear? Small d. So basically in that geometric concept, diameter is indicated with D, denoted with small d. Radius denoted by small r. Am I clear? So next one, arc. So arc, what is the arc? Arc is the part of the circumference where the largest arc is called the major arc and the smallest one is called the minor arc. So clearly we need to notice that. So let us draw the circle. So what is arc? Arc is a part of the circumference. So arc is a part of the circumference, just like that. So it is called arc. Am I clear? So arc is the part of the circumference where the largest arc, here largest, this is arc, these are largest arc is called major arc. It is a major arc. The smallest one is called minor arc. Am I clear? So clearly we need to observe this is a minor arc. This is a major arc. So arc is a part of circumference. If you take any part on the circumference, that is called arc. So here largest arc, this is the largest arc. It is a largest arc is called major arc, smallest arc is called minor arc, just like that. Am I clear? So let us go to sector. So what is the definition of sector? So what is the main sector in the circle? A sector of a circle is a pie-shaped slice of a circle enclosed by two radii and the arc between them. It's defined by a central angle and can be smaller minor sector or a larger major sector. So clearly we need to understand. So this is a circle. Am I clear? So a sector of a circle is a pie-shaped slice. This is very important. What? Pie-shaped cells of the circle enclosed by two radii and the arc between them. So it is always taken from the center. So two radii, just like that, two radii. So this is a radius, two radii enclosed by two radii and the arc. Enclosed by two radii and the arc. So this is called sector. It is two radii and enclosed by arc. So this is called sector. It is called sector. Am I clear? A sector of a circle is a pie-shaped slice of a circle enclosed by two radii and a arc between them. Arc between them, just like that. So it is called sector. So but it can be always sector always taken from the center of the circle. Okay, two radii means always taken from the center. So clearly we need to understand. So in that case, so what I'm given, it's defined by the central angle. It is defined by the central angle. That's like that. It is a theta. Theta is a angle of the sector. Am I clear? And can be smaller nothing but minor sector, larger nothing but major sector. So in that case, from the circle, two type of sectors can be obtained from the circle. So this is called smaller circle, but in that smaller circle it is called minor sector. Minor sector. Am I clear? So it is also sector. This is a larger part. It is also sector. Am I clear? So that is a clearly we need to understand that is a larger part of the sector. It is also called major sector. Major sector. Am I clear? So next one, chord. So what is the chord of the circle? The straight line that joins any 2 points on the circumference of a circle is called chord. So clearly we need to understand. So this is a circle. So what I'm given the definition? The straight line that joined any 2 points on the circumference. So this is the circumference of circle. Any 2 points. If you take any 2 points, they are adding. Okay, line can be obtained. That line is said to be chord of the circle. That means, so chord is the straight line. This is a straight line. So it can be joined any 2 points on the circumference of the circle is called chord. This is called chord. This is called chord. Am I clear? Clearly we need to understand. So chord means that is a straight line. That is a straight line. It is also chord, but the chord passes through center, it is called diameter. It is also called a chord passes through center is called diameter. This is also very important. Am I clear? So chord means what? It is a straight line joining any 2 points on the circumference is called chord. So it is also chord any 2 points on the circumference. It is a line, straight line joining any 2 points on circumference. It is also chord, but the chord is passing through center. So nothing but O. It is denoted as O. So is called diameter. Am I clear? So next one, tangent. So next one, tangent. A line that touches the circumference of the circle at a point is called tangent. So this is very important concept of the circle. What is tangent? A line that touches the circumference of a circle at a point, nothing but one point, is called tangent. So clearly we need to understand. For example, this is a circle. This is a circle. A line that touches the circumference. It is a circumference of a circle at a point. This is called tangent. This is a tangent. A line touches the circumference of a circle at a one point. A point means one point. This is called tangent. Am I clear? So this is also very important. So later I will explain the concept of tangent. Am I clear? Next one, secant. This is also very important. So a line that cuts the circle at the two distant points is known as the secant. This is a circle. Am I clear? A line that cuts the circle at two distinct points, nothing but different points. For example, so this is a line. So this line touches the circle at two different distant, nothing but different points is known as the secant. So this is called secant. Secant of the circle. Am I clear? So it is also secant. So a line cuts the circle at two distant, nothing but it is also secant. Distant points is known as secant. It is also secant. So what is a tangent? Tangent means a line touches the only single point on the circumference of a circle is called tangent. So that is the difference between them. If it cuts two distant points, that is called secant. It is touches only only one point. It is not a distant one point. Is called tangent. That is the difference between secant and tangent. Next one, segment. A segment of a circle is the region of the circle bounded by a chord and the arc that connects the chord's endpoints. Am I clear? A chord divides a circle into two segments. The minor segment, which has the smaller area, and the major segment, which has the larger area. So clearly we need to understand. So what is a segment? A segment of a circle is the region of the circle bounded by the chord, and the arc. So it is bounded by chord and the arc that connects the chord's endpoints. That is called segment. So clearly we need to verify it. So let us consider AB is a chord. Am I clear? So center is a O. This is a center O. So what I am given the definition segment. A segment of a circle is a region of the circle bounded by a chord. This is a chord. AB is a chord, and the arc. This is a arc. So it is also arc. So that connects the chord endpoints. A and B are endpoints. Am I clear? So this is called segment. It is that region is called segment. Just like that. So, but clearly we need to understand a chord divides a circle into two segments, just like that. This is a smaller segment, it is a larger segment. Am I clear? So here clearly we need to understand. So here smaller area segment is called. So what I am given the name? Minor segment. So larger area, this is a larger area segment is called major segment. Am I clear? Major segment. So next one, circles properties. First one, the circle are said to be a congruent if they are equal radii. So the circles, for example, let me take in two circles. So two circles, the radius are equal, nothing but radius of first one and second one are equal. Here R1, here taken R2. So R1 and R2 are equal. So these two circles are congruent. This is very important word. Next one, second point, the diameter of circle is the largest chord of the circle. This is also very important. So what is the diameter? So this is a chord which passing through center. So a line, so it is a chord passing through center. So it is called diameter, but here diameter is a largest, this is a largest chord. So it is also chord, this is also chord, this is also chord. So nothing but it is a line. So touches 2 points on a, touches the 2 points on a circumference of a circle is called chord. So yes, multiple chords can be drawn in a circle, but the largest chord is called diameter. This is very important word. So the largest chord of a circle is called diameter. Am I clear? This is very important point. Next one, equal chords of a circle subtend equal angles at the center. So this is a very important fundamental concept in geometry. So this is very important valid point. So what I am given, equal chords of a circle, just like that. It is a circle. So equal in circle contains center. This is a center. Okay, O. So what I'm given, equal chords. So for example, two chords taken. This is the first one, it is the second one. So let me take in two chords. So two chords, chord 1 and chord 2. So these lengths are equal. So equal chords of a circle subtended equal angle at the center. You can, so first chord subtended to the center. Second chord also subtended to the center. So equal chords of a circle subtended equal angles at the center. Suppose here, for example, theta value, for example, 60, it is also 60. It is also 60. This is a very important point. So here theta 1 and theta 2 are equal. Nothing but angles are equal. So equal chords of a circle subtend equal angle at the center. Just like that. This is two are equal chords subtended. Nothing but endpoints added to the center. So it is called radius. Two radius. Okay. It is also radius. So it is subtended equal angle at the center, just like that. So here theta 1 and theta 2 are equal. Am I clear? Next one, the radius drawn perpendicular to the chord bisects the chord. So this is also very important fundamental concept of geometry. The radius drawn perpendicular to the chord bisects the chord. So clearly we need to understand. So this is a circle. The radius drawn perpendicular to the chord. For example, so this is a chord. So let me take an AB is a chord. AB is a chord. Am I clear? So it is a center O. O is a center. So what I am taking? The radius drawn. This is a radius drawn perpendicular to the chord. Perpendicular to the chord. So the chord bisects the. That means the chord bisects the perpendicular to the chord bisects the chord. The radius drawn perpendicular to the chord bisects the chord. That means here. Let me take in that point is C. Here AC equals to CB. So the clearly we need to understand the radius. This is called radius. This is a radius. Am I clear? Radius drawn perpendicular to the chord. So AB is a chord perpendicular to the chord bisects the chord. Nothing bisects means what? AC equal to CB. Am I clear? Next one, circles having different radius are similar. Circles having, so suppose that two circles taken, two circles having different radiuses. So this is a radius R1, this is a R2. So first circle radius what I am taken R1, second circle radius R2 taken. So circles having different radius are similar. So both circles are similar here. Am I clear? So let's go to next point. A circle can circumscribe a rectangle, trapezium, triangle, square, kite. For example, triangle. Am I clear? A circle circumscribed, that just like that. This is called circumscribed. So in a triangle, square, or trapezium, rectangle. Next one, a circle can be inscribed inside a square, triangle, and kite. For example, if we take a square, this is a square. A circle inscribed, nothing but a circle drawn inside of the square. So it is called inscribed. It is called inscribed. A circle is inscribed in a this is inscribed, it is called circumscribed. So inscribed, circumscribed. So what is the difference between circumscribed and inscribed? A circle, clearly we need to understand, a circle is taken outside of the triangle or square. So that is called circumscribed. Inscribed means a circle inscribed in a nothing but inside of the square or triangle or kite. It is called inscribed. So circumscribed means circle appears outside of the given geometrical figure. So inscribed means a circle drawn inside of the geometrical figure. That is called inscribed. Am I clear? Next one. Next point, chords that are equidistant from the center are equal in length. So let us explain that point. The chords that are equidistant from the center are equal in length. So clearly we need to understand, this is a circle. Am I clear? Yes sir. Let me take chords that are equidistant from the center. This is a center, O is a center. Am I clear? O is a center. So two chords taken. For example, AB is a First chord equidistance means sorry, here OC. Second chord what I am taken? CD. So clearly we need to understand here AB and CD are chords, two chords equidistance from the center, nothing but if it is given equidistance from the center, that means that chords should be equal, nothing but here AB length equals to CD length. The chords that are equidistance from the center are equal in length, nothing but AB equals to CD. So let's go to next point. The distance from the center of the circle to the longest chord is diameter is 0. So longest chord nothing but diameter. Am I clear? The distance from the center of the circle, distance from the center of the circle to the longest chord is 0. So here which one is the longest chord in the circle? So if you draw the circle, so this is the longest chord, that is called diameter. Am I clear? So the distance from the center, this is the center of the circle to the longest chord, nothing but diameter. Diameter passes through center, nothing but distance is 0. Because the diameter, longest chord nothing but distance, diameter, longest chord nothing but diameter of the circle. Am I clear? So it is passes through center, nothing but what is the distance between center to diameter? 0, because it is passes through center. Am I clear? Next one. The perpendicular distance from the center of the circle decreases when the length of the chord increases. So this is also very important point. The perpendicular distance from the center of the circle decreases when the length of the chord increases. So clearly we need to understand. So this is a circle. This is a circle. A perpendicular distance from the center of the circle. So this is a perpendicular distance. So clearly we need to identify that. So this is a perpendicular distance. The perpendicular distance from the center, nothing but this is a radius. If radius is decreases, so nothing but radius, for example 10 centimeters taken, it can be reduced by 8, nothing but just like that. So clearly we need to understand this is a chord. So if it is reduced by reduced to 5 centimeters, so this is another chord. You can form another chord just like that. This is a perpendicular distance from the center means radius. So you can draw the, suppose that the perpendicular line, nothing but radius will be decreases, chord should be increases, just like that. So it is a smaller chord, this is a larger chord. Okay na? So this is a very important point. So what is the thought? If the circle, clearly we need to understand perpendicular distance from the center, nothing but radius of the circle decreases when the length of the chord increases. Am I clear? Clearly we need to understand perpendicular distance decreases, nothing but it is tends to towards the center. Automatically, clearly we need to understand the chord lengths are increases, just like that. Let's go to next point. If the tangent are drawn at the end of the diameter, they are parallel to each other. So this is also important point. If the tangent are drawn at the end of the diameters. For example, this is a circle, it is a diameter. So it is a diameter, nothing but it is passes through center. So this is a diameter. Am I clear? D. So what I am given the point, the tangents are drawn at the end of the diameter, they are parallel to each other. For example, tangent nothing but it is touches a point at the single point on a circle, the circumference of the circle, nothing but already given tangents drawn at the end of the diameter, just like that. So it is a tangent, it is also a tangent. Two tangents are drawn at the end of the diameters, nothing but these two tangents are parallel. This is also very important point. Next one. An isosceles triangle is formed when the radii join the ends of the chord to the center of the circle. An isosceles triangle is formed. So when will isosceles triangle has formed? When the radii is joining the ends of the chord to the center of the circle, just like that. So this is a circle. So let us check in. This is a center. Am I clear? So when the radii is joined, suppose two radii is taken, join end of the chord. So this is a chord. So end of the chord. So firstly, what you have taken, this is the center of the circle O. So this is a chord. This is a chord. Am I clear? This is a chord length. If it is added, joining, radii are joining ends of the chord, just like that. Ends of the chord. Am I clear? Ends of the chord means this is two radii. So this triangle, so what you have formed, here one triangle is formed, that should be a isosceles triangle. This is an isosceles triangle. Am I clear? Triangle. Yes. Next one. So what is the basic formulas of circle? Area of the circle A equal to pi r square. So here pi value 22/7. Am I clear? R stands for radius of the circle, but area nothing but always calculated in square units. If it's given centimeters, the radius given in centimeters, area can be obtained in square centimeters. When it is given radius in meters, the area obtained in meter square, nothing but square meters. Next one, the circumference of circle 2 pi r units. Because 2 pi r constant, r given in centimeters, circumference also in centimeters. So diameter nothing but 2 radius is called diameter. So it can be represented by d equals to 2r. So here r smaller represents the radius of the circle. Next one, semicircle. Half of the circle is called semicircle. It is a geometric shape formed when the full circle is divided into 2 equal parts along its diameter. So for example, this is a circle. It is a radius. Radius always passes through center. Am I clear? So this is a full circle. So it is a geometrical shape formed when a full circle is divided by into 2 equal parts along with diameters. So it is called half circle, nothing but semicircle. It is a semicircle. Half of the circle is called semicircle. Am I clear? Yes, sir. So next note is very important. There is a one and only one circle passing through 3 given non-collinear points. So these are 3 non-collinear points because they are not in a single line. So it can be drawn only one circle. When it's given 3 non-collinear points, only you can draw. So what is the second note? A circle cannot be drawn to pass through 3 collinear points. If it's given 3 collinear points, so collinear means it is touches as a line, just like that. So 3 collinear points means it is passing through a line. So a circle cannot be drawn to pass through 3 collinear points. When it's given 3 collinear points, that means you can add 3 collinear points. It's make a line segment. It is not a circle segment. So circle cannot be drawn through 3 collinear points, but one and only one circle can be formed when it's given 3 non-collinear points. Am I clear? So what I am given the question, given 3 non-collinear points, then the number of circles which can be drawn through 3 points is option A 0, option B 1, option C 2, option 3 infinite. So what I am given here, non-collinear points, 3 non-collinear points given just like that. So these are 3 non-collinear points. So how many number of circles which can be drawn through 3 points? Nothing but 3 non-collinear points. So already given that note. So when it's given 3 non-collinear points in a plane, so only one circle can be drawn from 3 non-collinear points. So option B is right answer. So next question, given 3 collinear points, then the number of circles which can be drawn through 3 points is option A 0, option B 1, option C 3, option C D infinite. So when it's given 3 collinear points, collinear means what? You can add these 3 points, it is passes a single line. It is called collinear. So is it formed a circle? No. So then answer is 0. Option A is right answer. So when it's given 3 collinear points, the number of circles which can be drawn through 3 points is 0 because it can be obtained line. So it is a line, not a circle. Option A 0 is right answer.